All right, today we're going to talk about solution stoichiometry. So solution stoichiometry is useful when we have reactions that are happening in aqueous. So double displacement reactions happen in solutions. So we have aqueous solutions being mixed, and then sometimes that solid precipitate comes out of that solution. So in this question, it says, what volume of 4 molar potassium iodide is required to produce 89 grams of iodine? So when we did stoichiometry before, it gave us masses. It would say, we had this many grams of potassium iodide. How many grams of solid can we make? This one's a little bit different because the solid is suspended in this solution. We have this 4 molar solution, and we have, at this point, an unknown amount of particles that are in there in grams, and we need to figure out how much of that solution we need to use to make that lead iodide. And we want to make a very specific amount of lead iodide, 89 grams. So how are we going to do that? Well, in stoichiometry before, we talked about when we use this balanced equation, when we relate two different things in the balanced equation, we're always going to be using our mole ratio. Remember, the mole ratio are the coefficients that are in the balanced equation. So this is a 2-to-1 ratio. In order to use the mole ratio, you have to be in moles. So currently, we are not in moles. We don't have moles in the problem that's in front of us. So when in doubt, go to moles. We will need to get to moles first so that we can use this balanced equation and then use that molarity equation that we learned as well. So our first step, we're always going to write what's given. And the best place to start for this would be our 89 grams of our lead iodide. So, So 89 grams of lead iodide. And I first will want to go to moles of lead iodide. So in order to do that, I must calculate its molar mass. So I have to look in the periodic table. We have 1 lead, which is 207.2 grams, and then we have 2 iodines, each of which are 126.9. So we get a total of 461 grams of lead iodide is in every 1 mole of lead iodide. So if I stop the problem here, that would give me moles of lead iodide. Okay, so now because we're in moles of lead iodide, now I can use that coefficient in the balanced equation to relate it to the potassium iodide in the question. And I do that by using those coefficients. This is a 1-to-2 ratio. So I know that for every 1 mole of lead iodide, I will need 2 moles of potassium iodide. Notice I put the moles of the lead iodide on the bottom because that's the unit that I'm trying to cancel out here. All right, so if I stop the problem here, I would know how many moles of potassium iodide I need. But notice I want to know volume, right? I want to know volume, and I'm given molarity, and now I have moles here from the problem. Remember, molarity is equal to moles over liters. And you can actually use that relationship, the relationship of moles and liters, as a conversion factor. So I know for potassium iodide, if it's a 4 molar solution, that means there are 4 moles of potassium iodide for every 1 liter of solution, which makes it pretty easy. So you're still just canceling out units as you go. Those first 2 steps we learned actually in first semester. That last step of using moles and liters as a conversion factor, that's the new piece here in this unit. So then we're ready to solve. To solve, we just multiply everything in the numerator and divide by everything in the denominator, and we should get 0.097 liters of Ki solution. So that's how much of the 4 molar solution I need to use, assuming I have enough lead nitrate. That's how much of that solution I need to use to make exactly 89 grams of lead iodide.